Are we alone in the universe? This question has led to countless stories, theories, and scientific pursuits. Throughout history, the twinkling stars and vast expanse of space have sparked a deep curiosity within us. Mankind has always gazed upwards, pondering this profound question. Recently, advancements in astrobiology and astronomy have brought us closer than ever to uncovering the mysteries of the cosmos. Today, as we step into 2024, our quest to unravel this mystery is not just a flight of fancy, but a journey grounded in scientific pursuit. In our galaxy alone, there are about 25 billion stars, like our Sun, and many of these are orbited by Earth-sized planets. This staggering number suggests a universe packed with possibilities. But with the infancy of our technological capabilities, we just haven't stumbled upon extraterrestrial neighbors yet. However, this is rapidly changing. We are on the brink of a new era in the hunt for extraterrestrial life. The upcoming deployment of advanced telescopes like the James Webb Space Telescope and ground-based giants like the Giant Magellan Telescope and the Extremely Large Telescope will transform our ability to study the atmospheres of distant planets. These enormous eyes in the sky will capture the faintest whispers of light from worlds hundreds of trillions of kilometers away, searching for the subtle signatures that life might leave behind. But the search for extraterrestrial life isn't just about finding another Earth. As we peer deeper into the universe, we also confront the profound possibility that life out there might be radically different from anything we know. The future of intelligence in the universe may be something beyond our wildest dreams. Some scientists speculate that as civilizations evolve, they might become so advanced that their intelligence transcends biological forms, possibly even harnessing the energy of entire galaxies. We may be looking for signals, not from fellow organic beings, but from entities of pure energy and consciousness. This mind-bending possibility reminds us that the universe is a place of infinite wonder, where the boundaries of reality are constantly being redefined. The search for extraterrestrial life challenges our understanding of existence itself. Life is amazingly tough. It can survive and thrive in places that we would never imagine. That's what recent research has shown us, opening up new possibilities for understanding life on Earth and beyond. Scientists have discovered and studied extremophiles, creatures that live in environments that we thought were impossible for life. These extremophiles are not just changing the rules of biology, they are also changing the way we look for life on other planets and moons. The exploration of extremophiles has revealed a world where life is not only resilient, but also flourishing, under conditions that challenge our conventional wisdom. From the boiling waters of deep-sea vents to the salty pools of desert salt flats, these microscopic explorers are redefining what it means to be alive. Scientists have found a variety of microbes, including heat-loving protists, algae, and fungi, that can live in temperatures above 50 degrees Celsius, using strategies like heat-resistant enzymes and protective substances to survive. These groups of beings also include thermophiles in scalding hot springs and hydrothermal vents, psychrophiles in the frigid polar regions and the dark depths of the oceans, and halophiles in the saltiest waters like the Dead Sea. These extremophiles have evolved unique strategies to survive. For example, thermophiles produce stable enzymes that function at high temperatures, while psychrophiles have specialized cell membranes and proteins that prevent freezing at sub-zero temperatures. The upper temperature limit for life was previously thought to be around 113 degrees Celsius, a record held by a microbe called Pyrolobus fumari. However, this was surpassed by strain 121, a microbe that thrived at 121 degrees Celsius. On the other end of the spectrum, certain microbes can grow at 12 degrees Celsius and survive at 20 degrees Celsius. Some studies even suggest that a bacterium called Colwellia Psychraerythria strain 34H can withstand temperatures as low as 196 degrees Celsius. But extremophiles are not limited to just high temperatures. Incredibly, certain species have adapted to live and develop in the deep sediments of the oceans and several kilometers inside the Earth's mantle, where they face extreme and fluctuating physical and chemical conditions, radiation, and heavy metal stresses. These discoveries are clues to the resilience and adaptability of life itself. The discoveries of extremophiles have implications that go beyond our planet. As we explore other worlds in our solar system and beyond, these extremophiles serve as guides, helping us to search for life in places that seem hostile to life. For example, on Mars, the discovery of liquid water and the possibility of high pressures look a lot like the conditions that some extremophiles endure on Earth. The same is true for the icy moons of Jupiter and Saturn, where there are oceans and volcanic activities under the ice, similar to Earth's extreme habitats. In deep-sea expeditions, researchers have gone thousands of meters below the ocean surface, traveling vents where hot material from Earth's interior meets cold ocean water. These studies not only show the strength of life under extreme temperature changes, but also improve our understanding of early microbial life and the potential for similar life forms on planets and moons with similar conditions. Beyond the extremophiles that mirror Earth's life, there exists the tempting concept of weird life forms that could have biochemistry radically different from what we know. Such life might not rely on water as a solvent or carbon as the basis of its biochemistry. For instance, life forms based on silicon rather than carbon, or using ammonia instead of water as a solvent, are conceivable under the laws of chemistry and physics. The search for these types of life forms expands the scope of astrobiology and our understanding of the diversity of life in the universe. This cutting-edge research on extremophiles is transforming our search for extraterrestrial life. By understanding how life can persist and thrive in extreme environments on Earth, we gain valuable insights into where and how to look for life elsewhere. As we continue to push the boundaries of our knowledge, exploring the most extreme environments on Earth, we inch closer to answering the age-old question: are we alone in the universe? Our search to the farthest edges of the cosmos extends as we take with us the lessons learned from the tiny, tough inhabitants of Earth's most extreme environments, reminding us that life, in its most stubborn forms, may be waiting to be found in the cosmos's vast, unknown spaces. While the possibilities of the tiniest life forms are too believable, an alien civilization still seems like sci-fi. No matter the constant shortcoming in searching for them, scientists have been looking for decades. One of the ways they do this is by looking for technosignatures, which are any clues that indicate the presence of technology created by extraterrestrials. Technosignatures can come in different shapes and forms, such as radio waves, megastructures, or even pollution. Radio waves are the most common and well-known type of technosignature. They are electromagnetic signals that can travel across the cosmos and carry information. The first serious attempt to detect radio signals from aliens was Project Ozma in 1960, led by astronomer Frank Drake. Since then, many projects have followed, using different telescopes and frequencies to scan the sky for possible messages from other worlds. However, radio waves are not the only way to communicate or reveal technological activity. Some researchers have suggested that we should also look for unusual chemicals in the atmospheres of planets orbiting other stars. For example, if we detect CFCs, which are synthetic substances that damage the ozone layer on Earth, we might infer that the planet has some industrial activity. Another possible sign of civilization is artificial light, which could be visible on the dark side of a planet and indicate the presence of cities or other structures. NASA is one of the leading organizations in the search for technological signals. It has funded and supported over 40 different projects that aim to find evidence of advanced life in the universe. These projects use various methods and instruments to look for different kinds of technosignatures, such as gamma-ray bursts, which could be caused by advanced spacecraft propulsion, and large structures that block the light of stars, such as Dyson spheres, which could be built by civilizations that harness the energy of their suns. NASA also uses artificial intelligence to help analyze the huge amounts of data collected by these projects, looking for patterns or anomalies that could indicate a technological signature. Artificial intelligence can also help generate new hypotheses and methods for finding technosignatures, as well as evaluate the likelihood and implications of different scenarios. One of the most ambitious and exciting projects in the search for technosignatures is COSMIC, which stands for Commensal Open Source Multimode Interferometer Cluster. COSMIC is a network of radio telescopes that operates at the Carl G. Jansky Very Large Array (VLA) in New Mexico, one of the largest and most powerful radio observatories in the world. COSMIC is designed to conduct one of the largest and most comprehensive SETI surveys ever, mapping about 75% of the sky and cataloging millions of radio sources. COSMIC is also unique in its collaborative and open-source approach, allowing scientists from different fields and institutions to use its data and processing power for various research purposes, such as studying pulsars, black holes, or galaxies. By doing so, COSMIC aims to broaden the scope and diversity of the search for extraterrestrial intelligence, as well as foster a culture of cooperation and transparency in the scientific community. As Carl Sagan, one of the pioneers of SETI, once said, "The universe is a pretty big place. If it's just us, it seems like an awful waste of space." By looking for technosignatures, we hope to find evidence of alien civilizations that have developed technology and perhaps learn something about their culture, history, and values. The concept of the habitable zone, or Goldilocks zone, as some like to call it, is a key concept in the search for life beyond Earth. It's the area around a star where the temperature is just right, not too hot, not too cold, for liquid water to exist on a planet's surface. And where there's water, there might be life. But the habitable zone is not the same for every star. For stars larger and hotter than our Sun, this zone lies farther out, where the heat is less intense. Conversely, around smaller, cooler stars, the habitable zone groups closer. Thanks to missions like Kepler, we have found many planets in these zones, some of them rocky and similar to Earth, orbiting red dwarf stars. However, these findings aren't a straightforward indicator of habitability. Planets around red dwarfs, for instance, face challenges such as powerful flames that could strip away atmospheres and sterilize surfaces, potentially extinguishing promising life. On the other hand, orange dwarf stars, which are cooler and dimmer than our Sun, might have more stable and long-lasting habitable zones. For instance, recent space weather modeling has suggested that superflares from stars could significantly impact exoplanets, affecting their potential for hosting life. The habitable zone is not just about temperature. The type of star and its activity, the planet's size, atmospheric composition, and even geologic activity all play a role in determining the true habitability of a world. A planet's composition, atmospheric pressure, and magnetic field are crucial for maintaining a stable environment. All these things can influence the climate, the greenhouse effect, and the protection from harmful radiation. And even if a planet has liquid water, it doesn't mean it has life. It also needs the right chemistry and conditions to support it. These factors influence the greenhouse effect, which is crucial for a warm enough climate and shield the planet from harmful radiation. Finding life in the universe is not easy. The habitable zone is a good place to start, but it's not enough. We need more advanced technology, like the James Webb Space Telescope and other future observatories, to study the atmospheres of exoplanets and look for signs of life, such as certain gases or molecules. We are on a quest to solve one of the biggest mysteries of all time. This zone is a complex and fascinating concept, It shows us the delicate balance that life needs and helps us in our search for it. But it's only one piece of the puzzle. The Goldilocks zone is a clue, a light in the darkness of space, pointing us to the worlds where life might exist. There are many other factors that determine the habitability of a planet and the existence of life. As we learn more and explore further, we get closer to the ultimate discovery, that we share this universe with other living beings. To answer our curiosity, NASA and other space agencies have been exploring our solar system and beyond, looking for signs of life on other planets and moons. In the near future, several missions and projects are planned or proposed to continue this search, with the hope of finding evidence of extraterrestrial life. Some of the upcoming missions include Europa Clipper, a NASA mission that will launch in 2024 and orbit Jupiter's moon, Europa, which is thought to have a global ocean of liquid water beneath its icy crust. The mission will study Europa's geology, chemistry, and habitability, and look for signs of plumes of water vapor erupting from the surface. JUICE is a European Space Agency mission that launched in 2022 and arrived at Jupiter in 2029. The mission will explore Jupiter and 3 of its icy moons: Europa, Ganymede, and Callisto. Ganymede is the only moon in the solar system with its own magnetic field, which could protect a subsurface ocean from radiation. Callisto is the most heavily cratered moon in the solar system and may also have a hidden ocean. Enceladus LifeFinder is yet to be fixed by a date. This proposed NASA mission would fly through the plumes of Saturn's moon Enceladus, which were discovered by the Cassini spacecraft. Enceladus is another moon with a global ocean of liquid water, and the plumes contain organic molecules and other potential indicators of life. The mission would analyze the plume material and search for biosignatures. Hera mission to Binary Asteroid System, KAISERV. The European Space Agency's Hera mission aims to send probes to a binary asteroid system consisting of an asteroid with a smaller orbiting counterpart. This follows NASA's successful mission to alter the asteroid's path. Hera will provide crucial data on the impact of this alteration and detailed observations of both asteroids, Dimorphos and Didymos. This mission is significant for understanding how to divert potentially hazardous asteroids from Earth. Mars Sample Return Mission. A joint mission by NASA and ESA, the Mars Sample Return Mission is an ambitious project to bring samples from Mars back to Earth. The mission involves sending a spacecraft to Mars to collect samples gathered by the Perseverance rover and then launching them back to Earth. This mission is crucial for studying the Martian environment and searching for signs of past life on the Red Planet. Lunar Gateway, part of NASA's Artemis program. The Lunar Gateway is an orbiting lunar outpost that will serve as a multi-purpose space station. It will facilitate lunar landings, serve as a research laboratory, and act as a staging point for deep space missions. The Lunar Gateway will play a pivotal role in long-term lunar exploration and serve as a testbed for the technologies needed for human missions to Mars. China's Chang'e 6 Lunar Sample Return Mission. Slated for launch in May 2024, China's Chang'e 6 mission aims to collect and return samples from the Moon. This mission is significant because it's planned to collect samples from an unexplored area of the Moon, providing new insights into lunar history and geology. Indian Space Research Organization's ISRO Gaganyaan mission. India's first manned space mission, Gaganyaan, is expected to be launched in 2024. This mission aims to send Indian astronauts to space and safely return them to Earth. It represents a significant milestone in India's space capabilities and will contribute to scientific research in space medicine and life support systems. Long-term human exploration. While human interstellar travel remains a distant dream, continued exploration of the solar system is expected. Future plans could include migrating to another planetary system, especially considering the eventual demise of Earth due to the Sun's transformation into a red giant. Such explorations could mirror cosmic events that have potentially occurred throughout the universe's history. These missions and projects could reveal a lot about extraterrestrial life, such as whether life is common or rare in the galaxy, and what factors influence its emergence and evolution. Whatever we have in store, each mission carries the hope of significant discoveries that could reshape our understanding of the cosmos and our place within it. We are like explorers sailing into the unknown, hoping to find new lands and new friends. Finding life beyond Earth would be one of the greatest discoveries in human history, and would have profound scientific, philosophical, and social impacts. Our journey through the cosmos, from studying Earth's extremophiles to probing distant exoplanets, inches us closer to answering whether we are alone in the universe. The discovery of extraterrestrial life, if it happens, would be an epic moment in human history, greatly altering our understanding of life itself. What will we find out there? And what will it mean for us? As we continue this search with advanced technology and ambitious missions, we not only seek to uncover the mysteries of the universe, but also to deepen our appreciation of our unique place within it. Did you know that there are more than 500 people who have lived in outer space? That's right! Since the first human spaceflight in 1961, hundreds of brave men and women have ventured beyond Earth's atmosphere, spending days, weeks, months, or even years in orbit. But what is life in outer space really like? You can float in the air, see the Earth from above, and witness the beauty of the universe. Sounds amazing, right? Well, that's what life in outer space is like. But it's not all fun and games. Life in outer space is also hard, risky, and challenging. It takes a lot of courage, skill, and dedication to survive and thrive in a place that is so different from our home planet. And it raises a lot of questions about our humanity, our responsibility, and our destiny. This video is about life in outer space. If you are anyone who is curious about space, the possibilities of what's beyond us, and how humans can live and work in the endless void, this video is for you. One of the first concepts we need to understand is what life is. A quality that distinguishes matter that has biological processes, such as growth, reproduction, and adaptation, from matter that does not. However, there is no single definition of life that applies to all possible forms of existence. We only know of life based on carbon, water, and energy. But there could be other types of life that we have not encountered or imagined yet. Life, as we know it, is a quality that distinguishes matter with biological processes such as growth, reproduction, and adaptation from inert matter. On Earth, we find life everywhere we look, from the deepest oceans to the highest mountains, from the hottest deserts to the coldest poles. Our understanding of life is based on carbon, water, and energy, but the universe might harbor other, unimaginable forms of life. These factors may vary on other planets or moons, and so may the types of life that could exist there. Considering the universe's vastness, with its billions of galaxies and stars, many of which have planets, the likelihood of extraterrestrial life seems high. Since the distances are also very large, it would take us thousands of years to reach the nearest star system with our current technology, and even longer to communicate with it. More than a scientific effort, the search for extraterrestrial life is a cultural and historical one. Humans have speculated about the existence of other worlds and beings since ancient times, and have expressed their ideas and beliefs in myths, religions, the arts, and literature. Some of the earliest Western thinkers who considered the possibility of an infinite universe with many civilizations were the ancient Greeks, such as Anaxagoras and Democritus. Later, in the 16th century, the Copernican revolution challenged the idea that Earth was the center of creation and opened the door for more scientific and philosophical inquiries about the nature and diversity of life in the cosmos. The 20th century opened the modern search for extraterrestrial life with the advancement of new technologies and disciplines, such as radio astronomy, space exploration, and astrobiology. One of the most influential figures in this field was Frank Drake, who conducted the first radio experiments to detect signals from other civilizations in the 1960s and proposed the famous Drake equation to estimate the number of intelligent civilizations in the galaxy. Another pioneer was Carl Sagan, who popularized the search for extraterrestrial life through his books, lectures, and TV series, and advocated for the exploration of the solar system and beyond. Notable missions such as SETI, Mars rovers, Cassini-Huygens, and the Kepler mission have expanded our understanding of potential extraterrestrial environments. The upcoming James Webb Space Telescope promises further insights into distant worlds. The search for extraterrestrial life is one of the most exciting and challenging endeavors of our time. It requires not only scientific knowledge and technological innovation, but also curiosity, imagination, and courage. It also raises profound questions about our place and purpose in the universe, and our responsibility and destiny as a species. By searching for life beyond Earth, we are also searching for ourselves. What would it look like, though, the life beyond us? The answer is not simple, as life could take many different shapes and sizes depending on the environmental conditions and evolutionary history of its planet or moon. They could be simple, single-celled organisms or complex technological beings that have evolved a high level of cognition, communication, and culture. But where do these extraterrestrial lives come from? The answer is also not straightforward, as life could inhabit various types of celestial bodies, such as planets, moons, and even asteroids. Planets in the habitable zone of their stars, where liquid water could exist on the surface, or moons orbiting planets in or near the habitable zone, where liquid water could exist under the surface. The other likely possibility would be asteroid belts or comets, where organic molecules and water ice could be present. Although this is a less likely candidate for hosting life, it's not impossible. Finding and communicating with extraterrestrial life would pose various challenges and implications for us, such as scientific, ethical, and existential ones. It would advance our knowledge and understanding of the universe and ourselves, but also raise many questions and issues. The only way for us humans to survive in outer space is by staying on a space station. A space station is a large spacecraft that orbits the Earth and serves as a home and workplace for astronauts and cosmonauts. The most famous space station is the International Space Station, ISS, which has been continuously inhabited since 2000 and can host up to 6 people at a time. So, what is a typical day like on the ISS? Well, it's not very different from a day on Earth, except for one thing. There is no gravity. This means that everything floats in the air, including people. This can be fun, but also challenging. A typical day on the ISS starts with a wake-up call. Astronauts then move on to personal hygiene, which is a tricky affair in space. Without gravity, water doesn't flow, so astronauts can't use showers or sinks to wash themselves. Instead, they use no-rinse shampoo and cloths to clean their hair and bodies. They also use wet wipes and toothpaste to brush their teeth. And they have to be careful not to let any water droplets escape, as they could damage the equipment or cause a short circuit. Eating in space isn't your usual affair either. Astronauts can't cook or store fresh food, so they rely on pre-packaged meals that are either ready to eat or need to be heated in a microwave. Using magnetic cutlery to keep their tools from floating away, and they have to be careful not to spill any crumbs or liquids, as they could clog the air filters or attract pests. Then there's work, like for the rest of us. Work is a mix of scientific experiments and maintenance of the space station. The lack of gravity means that working with liquids or small objects can be a complex task, as they tend to float away. Astronauts often use straps to anchor themselves when working. Finally, we have sleep. Sleeping in space is a unique experience too. Astronauts sleep in small cabins, each about the size of a phone booth, and they strap themselves into sleeping bags so they don't float around. While the cycle of the day sounds normal-ish, astronauts have to adjust their sleep cycles to the 16 sunrises and sunsets that they see each day, as the station orbits the Earth every 90 minutes. As you can see, living on a space station is very different from living on Earth. But it's not all about adapting to zero gravity. Living in space for long periods of time is not easy. It requires overcoming many challenges, such as radiation protection, sustainable life support systems, and mental health maintenance. These challenges affect the health, safety, and well-being of the astronauts and the success of the missions. Without gravity, muscles and bones don't have to support the body's weight, leading to their weakening over time. To counter this, astronauts spend around 2 hours each day exercising on equipment designed to work in space. Space also affects the human body in less obvious ways. For instance, fluid distribution changes, leading to a puffy face and thinner legs. Even the heart changes shape, becoming more spherical due to the lack of gravity. Psychologically, living on the ISS is a test of endurance. Astronauts are away from their families and the comforts of Earth for long periods, working in confined spaces with the same crew, which can be mentally taxing. To help manage these challenges, they undergo rigorous psychological training before their missions and have regular communication with their families and psychological support teams on Earth. Simple tasks can be challenging too, like cutting nails, as the clippings need to be carefully contained to prevent them from floating into the equipment. And the feeling of isolation is self-evident. Radiation protection is one of the most critical challenges of living in space. Space radiation consists of high-energy particles from the Sun, galactic cosmic rays, and trapped radiation belts around Earth. These particles can damage the DNA, cells, and tissues of the astronauts, increasing the risk of cancer, cataracts, and neurological disorders. To protect astronauts from radiation, space habitats need to have adequate shielding, such as water, metal, or polyethylene. Astronauts also need to wear personal dosimeters to monitor their exposure levels and take shelter during solar storms. Despite these challenges, living in space also offers many opportunities and benefits for the future of humanity. Many space agencies and companies have plans for extended space living, including missions to Mars and the potential for permanent human habitats on other celestial bodies. Missions to Mars are one of the main goals of extended space living. Mars is the most Earth-like planet in the solar system, with a similar day-night cycle, seasons, and climate. Mars missions could advance our scientific knowledge of the origin, evolution, and diversity of life in the universe, as well as the geology and history of Mars. Permanent human habitats on other celestial bodies are another possibility. Besides Mars, there are other places in the solar system that could host human settlements, such as the Moon, asteroids, or the moons of Jupiter and Saturn. These places could offer valuable resources, such as water, metals, or helium-3, that could be used for exploration, exploitation, or export. They could also serve as scientific outposts, tourist destinations, or cultural hubs for humanity. But as we adapt to the demands of living in space, one question remains unanswered. Are we alone in the universe? This question has fascinated humans for thousands of years and inspired many scientific and philosophical attempts to answer it. Beyond the confines of our space stations, the Artemis program and lunar exploration deepen our understanding of life in the cosmos. One of the main goals of the lunar exploration and Artemis programs is to search for signs of life on the Moon or evidence of past life that may have existed there. The Moon is a fascinating and mysterious place where we can learn more about the origin and evolution of life in our solar system and the potential for life elsewhere in the universe. Since more than 4 billion years ago, The Moon has been bombarded by asteroids and comets and exposed to the harsh radiation and vacuum of space. These events have shaped the surface and interior of the Moon, creating features such as craters, mountains, valleys, and lava flows. They have also left behind traces of water, organic molecules, and minerals that could be clues to the presence or absence of life on the Moon. The Artemis program is a robotic and human moon exploration program led by the United States National Aeronautics and Space Administration, NASA, along with 6 major partner agencies: the European Space Agency, ESA, the German Aerospace Center, DLR, the Japan Aerospace Exploration Agency, JAXA, the Canadian Space Agency, CSA, the Israel Space Agency, ISA, and the Italian Space Agency, ASI. It is intended to re-establish a human presence on the Moon for the first time since the Apollo 17 mission in 1972. Major elements of the program include the Space Launch System, SLS, the Orion spacecraft, the Lunar Gateway Space Station, and the Commercial Human Landing Systems. The program's long-term goal is to establish a permanent base on the Moon to facilitate the feasibility of human missions to Mars. This program will conduct multiple uncrewed and crewed landings on the Moon, starting in 2023. These missions will aim to study the lunar environment and prepare for human exploration. Some of the scientific objectives of the program are to map the lunar surface and subsurface, measure the radiation and temperature levels, analyze the water and mineral resources, test new technologies and systems, and search for biosignatures and fossils that could indicate the existence or past existence of life on the Moon. By doing so, the Artemis program will not only advance our knowledge and capabilities in space, but also address one of the most fundamental questions of humanity: are we alone in the universe? Stepping from the achievements and the collaborative spirit of the Artemis program, we now turn to a sector that's reshaping our journey into the stars: commercial human spaceflight. Commercial human spaceflight is not a new concept. In fact, the first private citizen to fly in space was Dennis Tito, an American businessman who paid $20 million to visit the International Space Station, ISS, in 2001. Since then, several other private citizens have followed in his footsteps, mostly through the Russian Soyuz program. However, these flights were expensive, rare, and dependent on government agencies. That is changing now, as new technologies, markets, and opportunities are emerging and more private companies and individuals are entering the space domain. One of the most prominent and ambitious players in this field is SpaceX. With a vision of making humanity a multiplanetary species, SpaceX has already achieved several milestones, such as launching and landing reusable rockets, sending cargo and crew to the ISS, and deploying thousands of satellites for global internet access. But SpaceX has even bigger plans for the future, such as sending humans to the Moon and Mars. To achieve these goals, SpaceX is developing 2 groundbreaking projects: the Polaris Dawn mission and the Starship rocket. The Polaris Dawn mission will feature the first-ever commercial spacewalk. A spacewalk, or extravehicular activity, EVA, is when an astronaut leaves the spacecraft and performs tasks in the vacuum of space, such as repairs, experiments, or exploration. Spacewalks are usually done by government astronauts, such as those from NASA or ESA, under strict protocols and supervision. However, SpaceX plans to conduct a spacewalk with 2 private citizens, who will fly on the Crew Dragon spacecraft to the ISS and then exit the station to perform a spacewalk with the help of a professional astronaut. This will be a historic milestone for commercial human spaceflight, as it will demonstrate the capability and safety of private individuals to perform complex and risky operations in space. The Starship rocket, on the other hand, is a massive and reusable vehicle that can carry up to 100 people and 100 tons of cargo to low Earth orbit, the Moon, Mars, and beyond. Starship is a two-stage launch system consisting of a booster called Super Heavy and a spacecraft called Starship that can land back on Earth and be refueled and relaunched, reducing the cost and increasing the frequency of space missions. A Starship is also versatile and adaptable, meaning that it can perform various functions, such as orbital refueling, lunar landing, interplanetary transport, and even point-to-point travel on Earth. Starship is currently under development and testing, with several prototypes and flights completed or planned. As we gaze into the future of space exploration, the unfolding chapters promise to revolutionize our approach to living and working in outer space. The advent of new technologies and materials science is at the forefront of this transformation. Spacecraft of the future will likely be built with advanced composite materials, offering enhanced protection against cosmic radiation and the wear and tear of space travel. These materials, lighter yet stronger, will pave the way for more robust and efficient spacecraft capable of withstanding the harsh environment of space while reducing the overall costs of space missions. Innovations in propulsion technology are equally significant. Ion thrusters, solar sails, and nuclear thermal propulsion are among the exciting developments that could drastically reduce travel time to distant planets and moons. These technologies promise to open up the solar system for more in-depth exploration and potentially even manned missions beyond Mars. Additionally, research into sustainable life support systems is gaining momentum. Efforts to develop closed-loop systems that can recycle water and air indefinitely are critical for long-duration missions and the dream of establishing human habitats on other celestial bodies. The integration of artificial intelligence and robotics in space missions will also play a pivotal role. Autonomous robots and AI systems could be used for tasks that are too dangerous or routine for astronauts, such as exterior repairs of spacecraft or initial construction efforts on lunar or Martian bases. This would not only ensure the safety of human crew members, but also increase the efficiency of space operations. The journey of humans in outer space, from the early days of orbiting the Earth to the current aspirations of interplanetary travel, reflects our relentless pursuit of knowledge and our unyielding spirit of exploration. As we stand on the brink of new discoveries and technological advancements, space exploration continues to inspire awe and wonder. It challenges us to rethink our place in the universe and compels us to continue pushing the boundaries of what's possible. Our quest to explore space is not just about reaching new worlds. It's about the growth, resilience, and ingenuity of humanity. As we look to the stars, we're reminded that the universe is not just a vast expanse to be explored, but also a mirror reflecting our own potential for discovery, innovation, and understanding. They still exist, whatever they may be. Although U.S. intelligence is pursuing them, its future study won't reveal the entire and definitive truth concerning UFOs. After decades of conspiracy theories, TV shows, movies, and presidents' sly jokes, the tantalizing promise of top government intelligence finally weighing in will instead produce a more banal reality that is unlikely to sway many people's opinions. What is the reality of aliens and UFOs? Do they really exist, or is it just a myth? Let's try to unravel the mystery around it. But before moving further, if you are new here, make sure to subscribe to the channel and hit the bell icon for such amazing content. Without further ado, let's get started. The sightings have not been linked to aliens, but there is no evidence to support this either, according to investigators. The U.S. administration is unable to provide a conclusive explanation for the aerial phenomena observed by military pilots, according to two people informed on the report due to Congress later this month. The report also leaves open the possibility that what the pilots may have witnessed was brand new technology created by another nation. There is no evidence, according to one of the authorities, that the unexplained phenomena are related to classified U.S. operations. The officials talked on the condition of anonymity because they were not authorized to disclose the material in public. The New York Times was the first to publish the report's findings. What exactly is the report? The report looks at numerous inexplicable occurrences that have occurred recently, some of which have been documented on video with pilots yelling about things flying in front of them. In December, Congress mandated that the Director of National Intelligence compile and submit a report on the U.S. government's understanding of unidentified aerial phenomena, or UAPs, also known as unidentified flying objects or UFOs to the general public. Officials from a Defense Department UAP task team created last year have participated in the project. According to one person, the anticipated public publication of an unclassified version of the study this month would merely be a status report and not the last word. Want to know about the take of the Pentagon? Sui Gaf, a Pentagon spokeswoman, declined to respond to media inquiries over the intelligence report. She stated that the Office of the Director of National Intelligence is actively working with the Pentagon's UAP task force on the report, and DNI will deliver the results to Congress. It has been decades since the Pentagon and the Central Intelligence Agency began investigating reports of aircraft or other objects in the sky traveling at irrational speeds or trajectories. Given the potential national security risk of an adversary using novel technology over a military base or other sensitive sites, or the possibility that a Russian or Chinese development will be more advanced than current U.S. capabilities, the U.S. government takes unidentified aerial phenomena seriously. Given that many of the pilots who reported encountering inexplicable aerial phenomena were flying combat training missions, the U.S. military likewise views this as a security and safety concern. Given that many Americans have a long-standing fascination with UFOs and the possibility that aliens have interacted with humanity, the report's lack of conclusive findings will probably disappoint some who were looking forward to it. The recent 60 Minutes segment on CBS further stoked interest in the government's findings. However, critics point out that there are plausible Earth-based explanations for the videos and sighting reports. The military should investigate any potential infiltration of U.S. airspace, especially by an enemy, according to the author, investigator, and veteran UFO skeptic Mick West. People are confusing this issue with the notion that these UFOs exhibit extraordinary physics and perhaps even contain alien life, according to West. There really isn't any clear evidence for the concept that this is some kind of secret warp drive, or that it's defying physics as we know it, he said. The Navy has established a system for its pilots to report any potential sightings, and the Pentagon last year announced the formation of a task group to look into the matter. Additionally, policymakers have pushed for increased public transparency in recent years. In May, Senator Marco Rubio, RFLA, said on 60 Minutes that there's a stigma on Capitol Hill. Some of my coworkers are quite interested in this subject, and some of them giggle when you bring it up. However, I don't believe we should let this stigma prevent us from knowing the answer to a very important issue. The U.S. Congress recently conducted a hearing to discuss U.S. government data on unidentified aerial phenomena, the UAPs. Project Blue Book, a U.S. Air Force inquiry that looked into reported sightings of unidentified flying objects, was where the last investigation of this kind took place more than 50 years ago. Note the change in name. The present hearings are the result of a clause in a 2020 COVID-19 relief measure that demanded U.S. intelligence agencies deliver a report on UAPs within 180 days, prompting the current hearings. It was published in June of last year. Why, then, would governments care about UAPs? One intriguing theory is that UAPs are extraterrestrial spacecraft that are visiting Earth. The idea is intriguing because it draws on decades of science fiction films, theories about what happened at Area 51, and alleged public sightings. An idea that is considerably more grounded in reality is that governments are curious about unexplained aerial phenomena, particularly those that occur in their own airspace, because they might be signs of enemy technology. The majority of the current hearings debate focused on potential UAP concerns because they are so clearly man-made technology. None of the evidence from the general people supported the idea that extraterrestrial spacecraft have crashed on or visited Earth. There were private, confidential sessions during the hearings that probably covered more delicate security information. Unexplained phenomena have undoubtedly been seen, as evidenced by the footage above, taken by naval pilots that show quickly moving aerial objects. However, making the leap to aliens necessitates far more solid and direct evidence, incredible evidence, that can be thoroughly examined with the aid of scientific methods. In the end, the possibility of life existing elsewhere in the universe is an intriguing one for both science and civilization. Therefore, the quest for extraterrestrial life is a valid endeavor that must meet the same standard of proof as other scientific fields. A drop in an ocean created curiosity among scientists. What was that? Over the past 10 years, I have intermittently employed radio telescopes to conduct extensive experiments in search of technosignatures or indications of technological civilizations on worlds outside of our galaxy, the Milky Way. But even after decades of numerous professional teams utilizing large telescopes, we haven't really covered much ground. Our decades of searching are comparable to plucking a random swimming pool's worth of ocean water out of the Milky Way to look for sharks, if the Milky Way is compared to the oceans of Earth. Furthermore, we aren't even certain that sharks exist, let alone what they would look like or act like if they did. The sheer size of the universe is an issue, even though I think life will almost surely exist among the trillions of planets in the universe. What would it take to make contact? It is extremely challenging to achieve interstellar travel, receive signals, or interact with any potential distant life forms due to the size of the cosmos, at least according to the laws of physics as we know them. The speed of light, or about 300,000 kilometers per second, is the upper limit on speeds. It moves fairly quickly, but even at that speed, the distance between Earth and the nearest star in our galaxy, which is 4 light-years away, would take a signal about 4 years to travel. However, according to Einstein's theory of special relativity, a physical object's speed, such as a spacecraft, will actually be slower than the speed of light in practice. Additionally, signals deteriorate according to the square of their distance due to the inverse square law of radiation that is deadly across intergalactic distances. Therefore, journey periods for planets hundreds or thousands of light-years away are probably in the many thousands of years range. Additionally, any signals coming from civilizations on those worlds are extremely feeble and challenging to find. Any cover-ups? Could it be, as Republican Congressman Tim Burchett said in his response to the hearing, that aliens have crashed on Earth and the US government is simply covering it up? The likelihood of a plane crash for airlines that are members of the International Air Transport Association is roughly 1 in a million. That raises the question of whether we would consider an alien spaceship that could traverse interstellar distances for tens of thousands of years to be more reliable and well-built than our aeroplanes. Think of it as being 100 times better. Consequently, the likelihood of a crash is 1 in 100 million. We would therefore require 100 million encounters with alien spaceships before we could wind up with alien wreckage hidden away at Area 51. That translates to 2,739 alien visits every day for the past 100 years. Where are they now? Aliens should always be active in the region near Earth. There should be a ton of really strong evidence in the hands of the general public and scientists, not just governments, with radars constantly scanning space, billions of mobile phone cameras, and hundreds of thousands of amateur astronomers photographing the sky, as well as professional astronomers with powerful telescopes. NASA is ready to start a scientific investigation into these enigmatic sky sightings, weeks after the first UFO public hearing in more than 50 years. A research team will be assembled by the American Space Agency to study high-risk, high-impact fields of study. The Space Agency insisted that they would sort the data that is already accessible, decide how to best collect data in the future, and choose how to use that data to increase scientific understanding of the problem. The unbiased team will evaluate the data that is already accessible to the public and attempt to determine how much more information is needed to confirm the veracity of the enigmatic encounters. We have no phobias about reputational damage. NASA's science mission chief, Thomas Zurbuchen, acknowledged that the traditional scientific community may view NASA as a kind of selling out by pursuing the contentious topic, but he vehemently disagrees. Our strong belief is that the biggest challenge of these phenomena is that it's a data-poor field, he said during a National Academy of Sciences webcast. This is what NASA refers to as the first step in its efforts to explain mysterious sky phenomena known as UAPs. A public report on the team's findings will be developed over the course of around 9 months, and the American Space Agency will invest anything from a few tens of thousands of dollars to little more than $100,000 in the project. The team of scientists is expected to meet by the fall. According to NASA, the team will be directed by astronomer and president of the Simons Foundation for Furthering Scientific Research, David Spergel. The only preconceived concept going into the investigation, according to Spergel, is that the UAPs will probably have a number of explanations. We must tackle each of these issues with humility. I spent most of my career as a cosmologist. I can assure you that 95% of the cosmos is unknown to us. We don't fully comprehend some things, Spergel stated. In the public briefing on UFOs held last month, Scott Bray, Deputy Director of Naval Intelligence, stated that since the early 2000s, they have observed an increase in the number of unauthorized and unidentified aircraft or objects in military-controlled training areas, training ranges, and other designated airspace. A report detailing observations of unidentified aerial phenomenon, or UAPs, made primarily by Navy personnel and put together by the Office of the Director of National Intelligence in cooperation with a task group directed by the Navy, was released by the U.S. government last year. Americans intend to cast ballots in the 2040 presidential election. Japan pledges to discontinue utilizing nuclear energy. Prince George will turn a ripe old 27 years old. Additionally, as the interactive up top shows, it's conceivable that alien life will be discovered. Depending on how many civilizations can be found, it might happen even sooner. Knowing about Frank Drake can assist you to comprehend why this is the case. The least lonely person on Earth, if not the entire galaxy, is Drake. Since we haven't even discovered bacteria yet, never alone an alien race that uses the internet and orders takeout, the majority of us are debating whether there is sentient life on other worlds. Drake, an astronomer and emeritus chairman of the SETI, Search for Extraterrestrial Intelligence Institute based in California, has no such reservations. The Drake equation, which determines how many advanced and detectable civilizations should exist in the Milky Way in a given year, was created by Drake in 1961 while he was working at the National Radio Astronomy Observatory in Green Bank, West Virginia. The number appears to be potentially enormous, and although it is admittedly built on a number of Earth-centric hypotheses, the collapse of any one of which calls much of the equation into question. All of those hypotheses are backed by research that is becoming more and more reliable. Start with the estimated 100 billion stars in our galaxy. However, it is sometimes stated that there are 3 times as many. Between 20% and 50% of those 100 billion stars likely contain planetary systems. This estimate is becoming more and more accurate, as more and more exoplanets are discovered by the Kepler Space Telescope and other ground-based telescopes. The equation estimates that from 1 to 5 in any system could support Earth-like life, because not all of those exoplanets would be able to. From 0% to 100% of those bio-friendly worlds would really go on to produce life. From 0% to 100% of those worlds would produce life forms that we would deem intelligent. However, unless sentient life forms have the capacity to communicate with us, that is, to control radio waves and other types of electromagnetic signaling, their mere existence tells us nothing. According to Drake, between 10% and 20% of intelligent civilizations would pass that threshold. The equation also takes into account how long each of those semaphoring civilizations would be able to blink signals in our direction, which is likely the most anthropocentric factor. A solar like ours lasts for roughly 10 billion years, whereas life has only existed on Earth for about 3.5 billion years. And people have only had access to radio since the turn of the 20th century. Our signal will be lost if we commit mass extinction tomorrow due to a nuclear or environmental disaster. The same is true for all of the other civilizations that exist in the Milky Way. If we live for tens of thousands of years, we will continue to announce our existence to the cosmos for a much longer period of time. When you combine all of this with a little statistical seasoning about how well we are now able to look for signals in other star systems, as the interactive above illustrates, the outcomes can vary greatly. You might find there are 1,000 identifiable civilizations out there at any given time if you play the game conservatively and underestimate all of the variables. If you play it more freely, you can win hundreds of millions. You can play the game for yourself using the interactive. Imagine there are 10,000 observable civilizations, and that by 2040, we will most certainly discover alien life. By 2028, if there are 1 million, we will have found alien life. The likelihood that the UAPs in the evidence are domestically produced or caused by undiscovered natural events is significantly higher. Occam's razor is still a wonderful place to start in science. The best explanation is the one that is the simplest while still being compatible with the data. Let's draw the conclusion that aliens haven't visited Earth yet, in the absence of much more and much better evidence. I won't lie though, I'm hoping to live to see the day when such proof is available. I'll keep looking to the skies to contribute till then. Do you also feel that we can someday encounter aliens and UFOs? What will be your reaction when you witness aliens and UFOs? Do let us know your answers in the comments below. And if you like our work, don't forget to like the video and subscribe to the channel. Thanks for watching.